Exercise 3, solving equations or quadratic equations by factoring and by graphing. If we look at graphing first, the zeros or the solutions are how many times and where the function crosses the x-axis. So if we look at example 1, we're looking at graphs that are already done for us and telling how many solutions each of them have. So if we look at the first function, a, we have two solutions here, one at 0 and the other at 3. So there, here we have two solutions. If we look at b, we have only one solution. We are stating the 0. So for a, we had 0 and 1, 2, 3. For b, we have 2. For c, we have 2 as well. And those are 2 and 3. And then for d, we have no solution. So wherever that line that's drawn crosses the x-axis is your zeros or your solutions. Zeros and solutions are the same thing. If we look at example 2, we are finding the zeros. So you got to think here. Do I have a greatest common factor? We're going right back to factoring. So back to chapter 2. So with a, do we have a greatest common factor that we can factor out? Yes. With both of these, they're both divisible by 2x. So we're going to factor out the 2x. We're going to have 2x times x minus 3 is equal to 0. Now, each part we're going to set equal to 0. So the 2x is equal to 0, and the x minus 3 is equal to 0. Solve for x for both. With the 2x, divide by 2 on both sides, we get that x is equal to 0. For the x minus 3, we're going to add the 3 to both sides, and we get that x is equal to 3. So 0 and 3 are our solutions, or our zeros. For b, again, do we have a greatest common factor? Yes, we have a negative 5x squared. So we're going to factor out that negative 5x squared. We're going to have x plus 4 left over. So we have negative 5x squared times x minus 4. Would be a minus. X minus 4 is equal to 0. From here, set both parts equal to 0. So the negative 5x squared is equal to 0, and then the x minus 4 is equal to 0. Solve for both. The negative 5x squared, we're going to divide negative 5 from both sides, get x squared is equal to 0, and then take the square root of both sides and get that x is equal to 0. For the x minus 4, we're just going to add the 4 to both sides, and we get that x is equal to 4. So we have 0 and 4 that are solutions. For c, we have 27x squared minus 18x is equal to 0. So our greatest common factor between those two terms is 9x. We're going to factor out that 9x. We're going to have 3x minus 2 left over. Set that equal to 0. Then set each part equal to 0. So 9x is equal to 0. And 3x minus 2 is equal to 0. From here, divide the 9. We get that x is equal to 0. Add the 2. We get 3x is equal to 2. Then we divide the 3. We get that x is equal to 2/3. So x is equal to 2/3 and x is equal to 0. Sometimes we're going to have to factor these. So with some of these, we're going to have to look at the trinomial and say, okay, can I factor out my c term to give me two numbers that are going to add up to be my b term? In this case, for example, a, x squared plus 5x plus 6 is equal to 0. So the 6 is 1 and 6. We also have 2 and 3. If they're both the same signs, the 2 plus 3 is going to give us that 5. So this is going to factor out to be x plus 2 times x plus 3 is equal to 0. Set them both equal to 0, so x plus 2 is equal to 0, and x plus 3 is equal to 0. Move the 2 over, move the 3 over. We get that x is equal to negative 2, and x is equal to negative 3. For B, we have x squared minus 7x plus 12. So the 12, we have 1 and 12, 2 and 6, 3 and 4. If they're both the same signs, negative 3 minus 4 is going to give us a negative 7. So this is going to be x minus 3 times x minus 4 is equal to 0. Set them both equal to 0. And solve. Add the 3. We get x is equal to 3. Add the 4. We have x is equal to 4. For our next example, we have negative 2x squared plus 26x minus 60 is equal to 0. So once again, do we have a greatest common factor? Yes, a negative 2. So we'll divide everything by a negative 2. This is going to give us negative 2 times x squared minus 13x plus 30 is equal to 0. Factor out that trinomial. We're going to have negative 2 times x minus 3 times x minus 10 is equal to 0. From here, set each part equal to 0. We have negative 2 is equal to 0, x minus 3 is equal to 0, and x minus 10 is equal to 0. That negative 2 is equal to 0 is a false statement, so we are not going to bother with that one. The x minus 3 is equal to 0. Add the 3 to both sides. We get x is equal to 3. For the 10, add it to both sides, and we get that x is also 10. So 3 and 10 are our solutions. When you have no b term with these equations, just move your b term over and take the square root of both sides. So with a, x squared minus 4 is equal to 0. Add the 4 to both sides. We have x squared is equal to 4. Then take the square root of both sides. Remember, if you're taking the square root of both sides in an equation, we add that plus or minus into there. So x is equal to plus or minus 2. For b, we're going to add the 36 over. We have 9x squared is equal to 36. Then we divide each side by 9. So x squared is equal to 36 over 9. Now, you can simplify this if you want to, because 3 goes into both of them. However, I wouldn't. The reason why is because you're taking the square root of both sides. So when you take the square root of that 36 over 9, you're going to get the same answer regardless, but sometimes you're not going to be able, like with D, you're not going to be able to simplify that fraction before you take the square root of it. So if you want to move it or leave it, you can. If not, you don't have to. 36 over 9 is also 4. So this is the same thing as x squared is equal to 4, which we would take the square root of both sides there as well and get that x is equal to plus or minus 2. For C, we have x squared minus 1 is equal to 0, so we're going to add that 1 to both sides, get x squared is equal to 1, then take the square root of both sides, so x is equal to plus or minus 1. And then with D, we have 121x squared minus 81 is equal to 0, so we're going to add the 81 to both sides. We have 121x squared is equal to 81. Then we divide each side by the 121. So x squared is equal to 81 over 121. We take the square root of both sides. Remember, when you're taking the square root of a fraction, it's both the numerator and the denominator that you're taking the square root from. So we're going to have x is equal to plus or minus 9 over 11. For our next part, we are writing these equations in standard form given the roots. So when we do that, we're going to take the opposite sign of the number, put it in parentheses with x, and then multiply out like you would when you FOIL. Make sure it's set equal to 0, and you're good. So for A, we have 2 and 5. So the opposite of 2 is negative 2. This is going to be x minus 2. The opposite of 5 is negative 5, so it's going to be x minus 5. We set this equal to 0. We FOIL. X times x is x squared. X times negative 5 is negative 5x. Negative 2 times x is negative 2x. Negative 2 times negative 5 is a positive 10. Keep it equal to 0. Combine your like terms. We have x squared minus 7x plus 10 is equal to 0. For B, we have negative 1 and negative 3. So again, take the opposites of them. So x plus 1 and x plus 3 is equal to 0. FOIL them. We get x squared plus 3x plus x plus 3 is equal to 0. Combine your like terms. Your answer is x squared plus 4x plus 3 is equal to 0. For C, we have negative 5 and positive 5, so this is going to be x plus 5 times x minus 5 is equal to 0. We FOIL, we get x squared minus 5x plus 5x minus 25 is equal to 0. From here, you combine your like terms, so we have x squared minus 25 is equal to 0. For D, we have 0 and 7. The 0 is going to be x plus 0. The 7 is going to be x minus 7. Set it equal to 0. FOIL. X times x is x squared. 0, or x times negative 7 is negative 7x. And then 0 times x is 0. 0 times negative 7 is 0. So we just have x squared minus 7x is equal to 0. For example 6, we are factoring and solving where a is not 1. So remember, when we did this, when we learned how to factor, once again, we multiply the a and the c, find the factors that add up to be b, replace b with those two factors, then factor by grouping. So if we look at a, we have 3x squared is plus 13x is plus 4. This f of x, we're going to change to 0. So we're just going to write it 3x squared plus 13x plus 4 is equal to 0. The 3 and the 4 get multiplied. 3 times 4 is 12. The factors of 12 that add up to be 13 are 1 and 12. So this is going to be rewritten as 3x squared plus x plus 12x plus 4 is equal to 0. We have 4 terms now, so factor by grouping. You're going to factor out an x from the first set of parentheses. You're factoring out a 4 from the second. So this is going to be x times 3x plus 1 plus 4 times 3x plus 1 is equal to 0. Your two parentheses are the same, so we are going to rewrite this as x plus 4 is equal to 0. X plus 4 times 3x plus 1 is equal to 0. Now set both parts equal to 0 and solve for x. So x plus 4 is equal to 0, and 3x plus 1 is equal to 0. Move the 4 over, subtract it from each side. We get that x is equal to negative 4. Move the 1 over for the other. We get 3x is equal to negative 1. Then divide each side by 3. We have that x is equal to negative 1/3, and x is equal to negative 4. For B, we have 3x squared plus 2x minus 5 is equal to 0. So this one's already set equal to 0, not f of x. So we don't have to change anything there. We start by multiplying the 3 and the negative 5. 3 times negative 5 is negative 15. Your factors of negative 15 that add up to be 2. 3 and 5 are our factors, so the 3 would have to be negative, the 5 would have to be positive to give us the positive 2. So we're going to rewrite this as 3x squared minus 3x plus 5x minus 5 is equal to 0. You have 4 terms, factor by grouping. 3x squared minus 3x, we're going to factor out a 3x. The 5x minus 5, we're factoring out a positive 5. So this is going to be rewritten as 3x times x minus 1 plus 5 times x minus 1 is equal to 0. So now rewrite this one more time. We have 3x plus 5 times x minus 1 is equal to 0. Set both parts equal to 0 now. 3x plus 5 is equal to 0, and x minus 1 is equal to 0. Move the 5 over, subtract it from each side. We have 3x is equal to negative 5. Then divide each side by 3. So x is equal to negative 5 over 3. For the x minus 1, we're going to add the 1 to both sides and get that x is equal to to positive 1 as well. For C, we have g of x is equal to 2x squared minus 5x plus 2. So that g of x we're going to replace with 0. So it's going to be 2x squared minus 5x plus 2 is equal to 0. Then we are going to multiply the 2 times 2, which is 4. Your factors of 4 that equal negative 5 are negative 1 and negative 4. So this is going to be 2x squared minus x minus 4x plus 2 is equal to 0. 4 terms, factor by grouping. The first set we're going to factor out as an x. The second we're factoring out a negative 2. So this is going to be x times 2x minus 1 minus 2 times 2x minus 1 is equal to 0. Rewrite again. We have x minus 2 times 2x minus 1 is equal to 0. Set both parts equal to 0 now. So x minus 2 is equal to 0, and 2x minus 1 is equal to 0. Solve for x, add the 2, we get that x is equal to 2, add the 1, then divide by 2, we get that x is equal to 1/2. So 2 and 1/2 are our solutions for this one. For D, we have 40x is equal to 8x squared plus 50. All of your terms are not on the same side, and you want them all to be on the same side. So we're going to move this 40 over by subtracting it from both sides. So this is going to give us 8x squared minus 40x plus 50 is equal to 0. Now, do you have a common factor? Yes, 2. So divide everything by 2. This is going to be 2 times 4x squared minus 20x plus 25 is equal to 0. Multiply the 4 and the 25. This 2 we can forget about because it doesn't have an x with it. So when we set it equal to 0, it's not going to be a true statement. So 4 times 25 is 100. Your factors of 100 that add up to be the negative 20 are going to be a negative 10 and a negative 10. So this is going to be rewritten as 4x squared minus 10x plus 25 is equal to 0. Factor by grouping. The 4x squared minus 10x we're factoring out a 2x. The negative 10x plus 25 we're factoring out a negative 5. So this is going to be rewritten as 2x times 2x minus 5 times 2x minus 5 is equal to 0. Your two parentheses are the same, so we're going to have 2x minus 5 times 2x minus 5 is equal to 0. Because both of these parentheses are the exact same, we only have to solve for one. So set one of them equal to 0 and solve for the x. Move the 5 over, add it to both sides. We get 2x is equal to 5. Then divide each side by 2. We have that x is equal to 5 over 2. For our next part, we are just solving by factoring. So with these, some of them you're going to have to factor, some of them you don't. You can move over. For A, the x squared minus 49 is equal to 0. We have difference of squares. So this is x minus 7 times x plus 7 is equal to 0. If we set both of these equal to 0, we are going to get 7 and negative 7 for our answers. For B, you have 64x squared minus 100 is equal to 0. So we can take the square root of both of those. We're going to have 8x minus 10 and 8x plus 10 is equal to 0. If we set both of these equal to 0, we're going to have 8x minus 10 is equal to 0, and 8x plus 10 is equal to 0. Move your 10 over, add it to both sides. You can do this for this equation, or if you want to realize that you have to subtract the 10 from the other equation, you can rewrite that one at the same time to be 8x is equal to negative 10. Then you're going to divide by 8 on both of these equations, so x is going to be equal to 5 over 4, and x is equal to negative 5 over 4. So you can leave it like this, or you can rewrite it as x is equal to plus or minus 5 over 4. For C, we have negative 225x squared plus 1 is equal to 0. So we are going to actually factor out a negative 1 in order to make this work. If we do that, we're going to be left with negative 1 times 225x squared minus 1 is equal to 0. So we can factor out the set of parentheses. We're going to have negative 1 times 15x minus 1 times 15x plus 1 is equal to 0. Set both of these equal to 0. We have negative 1 is equal to 0. We have 15x minus 1 is equal to 0. And 15x plus 1 is equal to 0. The negative 1 is equal to 0 is not a true statement, so we're going to cancel that out. The 15x minus 1, add 1 to both sides. We have 15x is equal to 1. Then divide each side by 15. We have that x is equal to 1 over 15. For the 15x plus 1, subtract the 1 from both sides. We have 15x is equal to negative 1. And then divide each side by 15. So we have x is equal to negative 1 over 15. So again, like I said, with the last one, you can rewrite this as x is equal to plus or minus 1 over 15. For D, we have x squared plus 10x plus 25 is equal to 0. So this is the same thing as x plus 5 times x plus 5 is equal to 0. We can do this as x plus 5 squared, because there's two identical parentheses, is equal to 0. Then we can take the square root of both sides, so we have x plus 5 is equal to 0. And then we just move the 5 over by subtracting it, and we have that x is equal to negative 5. For E, we have x squared minus 18x plus 81 is equal to 0. So we're going to factor this out. Again, this is the same thing as the last one. We have x minus 9 times x minus 9 is equal to 0 when we factor it. This is the same thing as x minus 9 squared is equal to 0. If we take the square root of both sides, we get x minus 9 is equal to 0. We add that 9 to both sides and get that x is equal to 9. For F, we have 4x squared plus 6x plus 9 is equal to 0. So this here is the same thing as 2x plus 3 times 2x plus 3 is equal to 0. So again, this is 2x plus 3 squared is equal to 0. We take the square root of both sides and get that 2x plus 3 is equal to 0. We're going to move the 3 over by subtracting it from both sides. So 2x is equal to negative 3, and then divide the equation by 2 on both sides, so we get that x is equal to negative 3 over 2. For our last set of examples, we're writing roots in vertex form. Vertex form is the form of f of x is equal to x minus h squared plus k. Now, when we do this, we are going to use the two numbers that they give us, take the opposite signs, put it into our standard form equation with it equal to 0. Identify your a, b, and your c, and use x is equal to negative b over 2 times a. Once we find this, we are going to plug it in for that equation wherever x is, and then solve it. Once you get what y is, you are going to use that in the formula of h comma k, which is the same thing as x comma y. H and x are the same k and y are the same. So when you do that, you just need your x, you need your y, and you're plugging it in to that formula. Your x is not going to change from the f of x is equal to x minus h squared plus k. So with this, we have 2 and 7. So this is going to be x minus 2 times x minus 7 is equal to 0. We're going to FOIL it out, get x squared minus 9x plus 14 is equal to 0. From here, your a is 1, your b is negative 9, your c is 14. You're using x is equal to negative b over 2 times a. Your negative b is negative times negative 9 over 2 times 1, which is 9 over 2. You are going to plug this in for wherever x is in that equation of that x squared minus 9x plus 14 and simplify. So this is going to be 9 over 2 squared minus 9 times 9 over 2 plus 14 is equal to 0. The 9 over 2 squared is 81 over 4. The negative 9 times 9 over 2 is negative 81 over 2. And then you have that 14. In order for you to add these, you need like denominators. So the 2 is going to have to multiply by 2, which means 81 gets multiplied by 2. The 14 is 14 over 1. You multiply it by 4, top and bottom, and you'll get your like denominators. So this is going to be 81 over 4 minus 162 over 4 plus 56 over 4 is equal to 0. So we add all of this or subtract it. The 81 minus 162 is negative 81. Negative 81 plus 56 is going to give us a negative 25 over 4. And again, this is your y. So if we get rid of that equal to 0 and we set it equal to y or f of x, which is y, we are going to be left with y. Now, you have an x, you have a y. This is the ordered pair, 9 over 2, comma negative 25 over 4. From here, you're going to plug this into your formula. Remember that formula that we said from the beginning was the f of x is equal to x minus h squared plus k. So we're going to have f of x is equal to, keep your x, minus h. Your h is your x value, so that's 9 over 2 squared plus k. Well, this k or this y is a negative, so it's going to be minus 25 over 4. So once you get your h and your k, or your x and your y, you're just plugging them into your formula. If we look at example B, we have negative 1 and 6. So this is going to be x plus 1 times x minus 6 is equal to 0. We're going to FOIL this to give us x squared minus 5x minus 6 is equal to 0. From here, our a is 1, our b is negative 5, our c is negative 6. So use your x is equal to negative b over 2 times a. So x is equal to negative times negative 5 over 2 times 1, which is 5 over 2. Now that you have your x, plug it in, solve for y. So y is equal to x squared, so 5 over 2 squared minus 5 times 5 over 2 minus 6. This is going to give us y is equal to 25 over 4 minus 25 over 2 minus 6. Least common denominator here with all of our fractions and all of our terms is 4. So this is going to become y is equal to 25 over 4 minus 50 over 4 minus 24 over 4. We combine our like terms here, or our fractions here. Remember, add the numerators, keep the denominator. 25 minus 50 minus 24 is going to give us negative 49. So y is equal to negative 49 over 4. Remember, you have h comma k or x comma y. So this is the ordered pair. That's 5 over 2 comma negative 49 over 4. Plug it into your formula. Remember, your formula is f of x is equal to x minus h squared plus k. The x stays. So your answer for this one's going to be f of x is equal to x minus 5 over 2 squared plus 49 over 4. For your next one, example C, we have 0 and 9. So this is just x plus 0 times x minus 9 is equal to 0. We FOIL it out. We get x squared minus 9x is equal to 0. Your A is 1, your B is negative 9, your C is 0. So x is equal to negative b over 2 times A. This is going to give us negative 9 times negative 1 over 2 times 1, which is just 9 over 2. So x is 9 over 2. Plug that in to your formula for y is equal to 9 over 2 squared minus 9 times 9 over 2. 9 over 2 squared is 81 over 4. Oops. 81 over 4. Minus 9 times 9 over 2 is negative 81 over 2. If we turn these into like denominators here, we're going to have y is equal to 81 over 4 minus 162 over 4. So this is going to give us a y of negative 81 over 4. So again, our x is the 9 over 2. Our y is the negative 81 over 4. So this is going to give us an h of 9 over 2 and a k of negative 81 over 4. So f of x is equal to x minus, what was our x? 9 over 2 squared plus 81 over 4, which is our k. And then for our last one, we have negative 5 and negative 8. So this is going to give us x plus 5 times x plus 8 is equal to 0. We FOIL it out. We get x squared plus 13x plus 40 is equal to 0. Our A is 1, our B is 13, our C is 40. So we are going to use x is equal to negative b over 2 times a to give us negative 13 over 2 times 1, which is just negative 13 over 2. We plug that in. We're going to have y is equal to negative 13 over 2 squared plus 13 times negative 13 over 2 plus 40. The negative 13 over 2 squared is 169 over 4 plus the 13 times negative 13 is negative 169 over 2 plus 40. Like denominators here is 4, so this is going to be y is equal to 169 over 4 minus the 169 times 2 is negative 338 over 4 plus the 40 over 1 becomes 120. Oh, sorry, not 120, it's 160. 160 over 4. So we add all these up. We have 169 minus 338 plus 160 is negative 9 over 4. So y is equal to negative 9 over 4. Our x was negative 13 over 2. Our y is negative 9 over 4. So this is the order pair negative 13 over 2, comma negative 9 over 4, h, comma k. This is going to give us the equation f of x is equal to x plus, our h, which is 13 over 2 squared plus 9 over 4. The reason why that plus sign is in between the x and the 13 over 2 is because originally it was minus, and the 13 over 2 is negative, so it turns into a positive.